Good morning, team. I had a couple of people email me and they wondered how to do this spectroscopy lab. So let me show you how to do it. There's a few parts of it that are a little quirky when it comes to the interface. So just want to take about 5 minutes to show you this. I am feeling a little sick this morning, so apologize for the voice. But all you do, of course, download this. You can open it in Word or you can upload it to Google Docs and open it in Google Docs. It's a little bit, the formatting's a little off in Google Docs, but you can still get the information. So I've downloaded it here. Now all you do is you go down to this link here. So click on that. Okay, and now here's what's a little bit funny. As you're going through this, you'll read the background information, and the key here is this, okay? When it comes to the sun, when you separate out the different wavelengths of light, you get the full spectrum of light, okay? Now, we'll talk more about the electromagnetic spectrum, but the light is the only portion, visible light is the only portion we can see. The electromagnetic spectrum, though, extends far beyond in both directions, okay? As you go to the top here, the wavelengths get shorter and the energy gets higher. So as you go up, you get to things like ultraviolet, then you get to X-rays, and you get to gamma rays and things like that. It gets stronger and stronger. Whereas down here on the bottom, on the red side, you get to infrared, and then you get to microwaves, and then you get to radio waves, and those waves get larger and less energetic. So that's the electromagnetic spectrum. But what's unique is this. This is called the line spectrum for a certain element, a certain gas usually is what you use. And it's unique because here's what's different. You'll notice that there are only certain spectrums that show up. There's only certain wavelengths, I guess I should say, that show up. So you have blue here, you have kind of an aqua color and a darker blue, and then you have the red. So this was something that was discovered quite a while ago that was unusual, but it helped to prove that there are specific energy levels that electrons must reside in, essentially. So, and here's the way you want to think about this. They give this example, and that's this ladder, okay? It's the way it works is if you imagine yourself as an electron, you can step up one rung, you can step up 2 rungs, you could even jump down from 2 rungs down to 1 rung, okay? But you cannot stop in between rungs. Here is the key. When electrons or when gases emit light, that is caused by electrons that have first jumped up energy levels. Usually they jump up energy levels because something like electricity has been run through them. Maybe they've been put on a very heavy flame, a very hot flame. Whatever it might be, something has caused them to jump up in energy levels. When you see them emit light, what they're doing is they're falling back down. Whenever an electron falls closer to the nucleus, it will emit energy. And it emits that energy, in this case, in the form of visible light. Okay? So as you can see here, here's the key. The reason you only get certain lines on this spectrum is because those electrons can only drop specific amounts. They cannot drop halfway through. If electrons could stop anywhere they sort of wanted, then you would get a full spectrum of light. But because they can only stop on energy levels, or in the metaphor here, on rungs of the ladder, then you only get specific wavelengths. And that is the key to this lab. But the thing you may not have understood is that down here it says click on the elements below to view the emission line spectrum, the emission line spectra, and record your observations. So you just click on this. I know it doesn't look like a link, but it actually is. So you click on that, and then you go down and you go to your paper, and let me show you the paper here. You go here, and then you write down, you circle whatever you have. So you put the name of the gas here, like I might put mercury here, and then I look at the spectrum, and I say, okay, mercury has blue, so I would circle blue. And then it has green, and it has red, maybe orange, but you kind of look at it. And what happens is every one of these gases have a very unique line spectra. None of them are alike, okay? And that's what you're going to be analyzing in this lab, is why a certain why a certain gas or a certain atom has its own unique line spectra. Okay, and it is actually pretty fascinating, because this was the way that we discovered helium, was because we saw this line spectra coming from the sun, and we couldn't explain what it was, and so we realized later on that that was helium. That was the second element on the periodic table. And later on, we discovered it was actually on the Earth as well. But prior to that, we didn't know that. So that's an example of how these line spectra can be used. Same thing with the one below here. If we go down here, same thing here. Flame color. This is the same idea going on. And that is that as different elements, because of their unique configuration of electrons and how their energy levels stack up, in a sense, they will, when you heat certain elements over a flame, they will release light that is unique to those elements. And so here you have some different colors. That becomes a good way to identify these different elements. And you can see calcium, barium, rubidium, potassium, and lithium and sodium. Most of these are group 1 group 1 metals. We'll be talking more about the periodic table later. So hopefully that helps you a little bit in figuring out how to do this lab. Good luck on it. It is due tonight, and then we have some other assignments that will be due. They'll be due on Sunday night, but obviously I don't want you to work on them on Saturday and Sunday. I would rather you go out, do something fun. So try to finish those today. Send me an email if you have any questions, and I'm going to be putting together a couple of lectures this weekend that I think is going to help you understand electron configuration better. But what I'd like you to do now is just do the best you can to understand it. I know it's confusing initially, but I know we're going to clear it up once we talk about it in a recorded lecture here on Monday. Thanks a bunch. Have a great weekend.